Okay, here's the next installment in my Bearhawk saga. So you can see behind me, I've got the fuselage set up on the jig table, and also I've got the wings that are tack welded to the fuselage itself. So that's all done. So now what I have to do is I have to make all the little bits and pieces that fill in the gap on the top of the fuselage between the wings. And they're all shaped and they're all made to the shape of the wing. But there's a funny little piece right at the very top, and it's used to capture the top edge of the windshield, and here it is on plan drawing number 16. And you can see there it is right there. That T10 is the horizontal tube that holds that windshield piece up, and it says to make it out of 32 thousandths mild steel. So I measured between here and here where this radius starts, and that's 5/8 of an inch, and then there's the return there, so I don't know what the makeup is on that yet. And then there's 5/8 of an inch here, and then a little flange coming down here to weld onto the T10, skip welded. It's a little complicated to make. There's a lot of different ways to do it, but I'm going to show you how I did it and how I made it. First off, I decided to go ahead and make a jig, and you can see that what I needed to use is something that would make the 1/4 inch gap easy to obtain, and I used a 1.5 inch wide piece of angle that's 1/4 inch thick, and this happens to be 44.5 inches wide. The piece up top needs to be 43 inches wide, so this is a little bit longer, and that's what it needs to be. It needs to be a little bit longer. I wouldn't go any shorter than 44.5, but you can certainly go up to 48 or even longer if you like, but then it starts getting hard to handle. But what I did with this piece is I went ahead and just cleaned up the edge. Didn't do anything fancy to it, no milling or anything like that, just cleaned off the rust because it came out of my scrap pile. And for a backing rod, or backing, I guess, piece of steel, I had a 48-inch long piece of 1/2 inch by 1.5 flat bar stock that's pretty dang straight. So that's what I used to go ahead and form it. I'm going to show you how I went ahead and used these pieces to make these channels here, and how to turn a piece of this into that. Okay, first step is to determine how wide a piece of sheet metal I need to cut in order to make the channel that fits the top of the windshield. I already know that the width of the fuselage from one side to the other is 43 inches, so that's already determined. But how to determine how to make this bend here and what we need to do to make that happen as far as the return and the makeup. So I know that the front flange, according to the plans, is 5/8 of an inch. So what I did was I took a little piece of steel, which is the same as what I used for making the flange, and starting at 5/8 of an inch at 1/8 inch increments, I went ahead and just drew a line. I went ahead and clamped that in place underneath my a little bar that I had, and I lined up that very first line with the edge right where it starts to make that rounding, or the rounded edge, all the way around to the back. I put a clamp on it here, and actually a clamp on both sides, and then I went ahead and I bent the coupon all the way back around until it was flat up against the other side, and it worked really well that way. And then what happened was then I had a measurement going from one side all the way to the other, and I figured out that it takes 3/8 of an inch of material to go from this side all the way over to this side. In other words, that's the makeup that I need to add to the entire width of the piece that I need to cut. So I've got 5/8 of an inch here, 3/8 of an inch here, and then another 5/8 on the bottom. So that gives a total of 13/8 plus whatever I have down here to make the flange. I just went ahead and added an inch, so it'd be another 8/8. So it's a total of basically 2.5 inches what I need to cut to make the width of this metal work for the flange and to make up this piece. I'll show you how to do that next. Okay, now that we determined the width of the piece of sheet metal, we need to mark it out on the sheet metal itself so we can cut it to width. And if you can see, I've got 4 marks there on the sheet metal itself. The first mark is 5/8 of an inch back. Actually, it's fudged a little bit. I went ahead and went to 11/16 just for giggles, because in case I'm not completely accurate as far as putting this piece on the jig. I'll still have enough meat left over when I fold the metal over that it'll be enough to capture the windshield. That's the most important part. The next mark over is 3/8 of an inch over, and that's what does the makeup for the 180-degree bend. The third mark over to the right is where the 90-degree bend starts to make up the flange that gets skip welded to the T10 tube. And then the last one that you can see over to the right with the arrow pointing to it, that's adding just about an inch, a little bit more than an inch, to the width of, or to that flange to help stabilize the piece when I'm doing the forming. And I'll cut that to length once I get the piece finished. But that's where I need to start, and that arrow part, I'm going to duplicate that over on the other end of the piece of sheet metal. Then I'll go ahead and cut it in the shear, and then I'll trim it back to 43 inches. This piece of sheet metal happens to be 48 inches wide, but we don't need the extra 5 inches, so I'm going to trim off 5 inches off of that to get to the 43. Okay, you can see that I've already went ahead and I sheared off just a little over 2.5 inch wide piece of sheet metal, and I trimmed it to 43 inches wide. And this is what's going to go into the brake. Now, other people, when they do this, they put the flange on last, but I figured putting the flange on first would be better. And the reason for that is because when it gets put into the jig, when it's pounding the flange over, that 90-degree bend in the bottom will help stabilize the piece and add some strength to it, and help keep it from bending like a banana. We experienced that when we made the ribs for the horizontal vertical stabilizer, and the same thing applies. Anytime you can add some structure to the sheet metal before you form it, it's going to help. So I went ahead and made the marks here on the end, and this is what I'm going to use to line up in the brake. I've got these marks again. This is, again, it's not 5/8, it's 11/16. Give a little bit of fudge factor in there just in case, because the top flange, having that long enough, is critical to make sure that the windshield gets captured. 3/8 of an inch here, and that is the bend radius. And then 5/8 for the bottom half of the windshield mount. And then this is going to be the tail that gets welded to the T10. And where I'm going to put the bend, the 90-degree bend, is right here at this mark. I've got it marked on the other end as well. So we're going to put it as close as we can in the sheet metal brake to that bend. This little piece here, this is going to be cut. When it's all completed, it's going to be cut down to almost maybe 1/4 of an inch wide, so it can be skip welded to that piece of tube. But first we've got to get a piece that's all formed before we can start cutting that. Okay, you can see what I've done here. I've went ahead and placed the piece of sheet metal into the sheet metal brake. I've got the one mark lined up here on this end and the other mark lined up on this end. And all I'm going to do is I'm going to go ahead and ease it up just really slowly and go ahead and put that 90-degree bend in here. These brakes are notorious for slipping, and I don't care how careful you are, but if you have this too tight, then it's really hard to get an accurate placement of the sheet metal. If you get it too loose, then the sheet metal is going to tend to slide underneath as you put pressure on it. So I've got the tension adjusted properly here, good enough for what I'm doing right now. And all I'm going to do is go ahead and ease up on it and make that 90-degree bend. And there will be some spots that go a little bit over 90, some that are right at 90. And like on the very ends here, this is a little bit more than 90. So while it's still in the press or in the brake, I'll go ahead and I'll pull it out just a little bit, just to match the rest of it. Here in the middle, it's all at 90, and here on the other side here, it's a little bit more than 90. So then I release it. And there we go, got the first step in the process. It's a nice crisp bend, not too tight, proper radius. It looks really nice and smooth. So now I'm going to go ahead and set it up in the vise. Okay, this is probably the most critical part in the whole process, is making sure that you have a straight, equal bend all the way along the entire length of the piece of metal. What I've done is I've just balanced right now my little piece of 1.5 inch by quarter angle iron on the jaws of the vise. I went ahead and put the sheet metal down, and then I've got the bar here that's the backer bar essentially for when I do the bending. And I'll show you that here in just a second. But just to lay it out, just to put it in so I can start clamping it in place. If you can see the marks here, you got the one makeup mark here at the back, and then the other 3/8 mark, and this is what ends up making the top part of the flange. So you want to make sure to line up this mark with right where the bend in the angle iron starts, and then place this bar right over the top of that to help back this portion up when you bend it, because otherwise it'll give that little wow in the back of the sheet metal, like we talked about in the rib forming. If you don't have a tight enough backer block, the sheet metal will actually go up and then come out and then go back around and make kind of like a little bit of a P shaped in the back of the bend. And that's what we want to avoid when we're doing this kind of thing. And you can see it's already aligned over here too. The next part is to clamp all this in place and start putting it over. Okay, here's the end result of all the clamping and everything that I did once I got it all lined up. As you saw before, it was turned about 90 degrees from where it is now, and I clamped these two on the end just to make sure to get them stable. Then I went ahead and put some wood blocks, if you can see, here in the vise to help support this. And this is clamped here all the way just to where that bar is showing just a little bit above. I just want a little bit of clearance on the back side. And then I've got some C-clamps holding the 1/2 inch by 1.5 inch bar all the way along the entire length. What I'm going to do now is I'm going to go ahead and I'm going to hammer this down to a 90-degree bend, and I'll tell you why that's important just to start that out. But we'll go on from there. Okay, now we're going to go ahead and start making this bend here, the very first bend on that return, making that 3/8 of an inch bend here, and this is the top part of the flange. I'm going to go ahead, I'm going to start bending from the sides in, and then very gradually. The reason why is because if you start folding this down too aggressively all the way along the length, anytime that you take the sheet metal and you put a little bit of a twist to it, that actually lengthens the cord. In other words, you're stretching the sheet metal on the back side. What that does in effect, that will put a bow into your piece. It's almost unavoidable to have that bow, but you can really minimize it by taking your time and going ahead and just really going softly as you're going, and we're just going to a 90-degree bend. So earmuffs on, I got my soft blow hammer, and we're going to go ahead and start. So now you can see how slowly the process goes. I've just got just a tiny bit of a bend on it. And if you look at it, when I was hitting with the hammer, I was coming at it a little bit from the side. It gives me a little bit better control. And also I'm hitting more towards the base, right where the two pieces of metal are clamped together instead of on top. And that gives me a lot sharper bend towards the bottom. So I tend to favor that, and like I said, I always go towards the middle. If there's going to be any bending going on, hopefully it will be captured and rolled into the middle and it will counteract itself. So I'm going to go ahead and turn the video camera off, because all I'm doing now is just going ahead and hammer it the rest of the way, so it'll take a few minutes to get it done to the next step. Okay, a couple minutes later, you can see I'll go ahead and I went ahead and hammered this down flat. You can see I really favored this part of the metal all the way down, just getting it nice and tight up against the piece of angle with that 1/4 inch radius. And you can see here's my 3/8 inch mark right here. So it's about halfway around. Once I wrap this around, then that mark will be right on the back edge of this, which will indicate that we did get a good radius on here. One thing I want to caution you also, see how these C-clamps are done? And I did this on purpose. You can see there's a little bit of a dimple here. That's the back side of this clamp, because it's just sticking up just a tiny bit. Be real careful when you get up to the 90-degree bend that you don't get too far to where you're starting to go ahead and put little whoop-de-doos in there just like this. And the reason I point that out is because the first piece I did, that's exactly what I did. But I just did this for demonstration purposes. So now we got to take this out of the vise and move it around a little bit and move some clamps around, and I'll show you how to finish it off. Okay, the final step in the process is to continue bending this over to 180 degrees. If you remember, I had this thing sitting down lower in the vise, and it couldn't go down lower than a 90-degree bend just because it would interfere with the vise and the clamps. So what I did was I went ahead and put another little block of wood underneath the angle and put up just so the vise captures the 1/4 inch angle in its jaws right at the very top. I took the middle field clamps off from this. It's not as critical as you would think at this point. You can go, or I will go, with the soft blow hammer, and I'll go ahead and make the rest of the bend all the way around. But what I'll do is I'll have my hand like this as I'm moving along with the hammer, and I'll go ahead and ease its way all the way around. Again, just going very slowly, but the main work that this bar did was doing this 90-degree bend. Now all we're doing is going the rest of the way over, and the pressure on this bar is now a lot less critical than it was when we did the first 90-degree bend. Okay, so here we go. I'm going to go ahead and put the rest of the bend on the top part. Earmuffs on, and going to go ahead and just start working my way from one end to the other. Again, you can see that with my hammer, I'm favoring this back side. I'm not hitting on the front edge because that'll put a little bit of a bow to it. What I want to do is I want to bring the metal over this radius on the 1/4 inch piece of, or 1/4 inch thick piece of angle. I want to go ahead and strike it here to help bring the metal around instead of whacking it way up here, because that'll end up putting more stress on that front part and not getting the nice sharp crisp bend right on the back. So I'm just going to go ahead and keep on hammering over and start it again when I get done. Okay, once you get to this point, I've got it almost all the way down to 180-degree bend. You can see that it's flat, just about flat up against the angle here, and I've got the vise swivels, and the only reason I did that is so I can at least view in the camera, and I can show you what I did once I get it to this point. Once you get it down to 180 and you get here right on the sheet metal, you can really get whacking on this thing and whack really hard. Just like that, and it'll make it smooth all the way down. You can really work on it, but make sure you're using a soft blow hammer. Use a regular hammer, you're going to just end up tearing up everything here. And one word of caution, when you're hammering on this thing, either the first time or the second time, especially once the middle clamps are off, these end clamps will tend to vibrate off. I guarantee that they'll fall off once or twice. Don't get discouraged because you've already have this set. So to clamp it back together, all you got to do is just push it down to where it's right up against the 1/4 inch thick angle, and go ahead and tighten the clamp back up again, and you're good to go. No big deal. So I'm going to go ahead and whack on this thing and make it nice and flat, and then we're going to be done. Okay, moment of truth time. Time to take the clamps off and take a look and see how the piece turned out. It should slide right off, and it does. It's good. It's got a little bit of a bow to it. That's right, we can work that out. You can see. But you can see on the end profile here how that was made. I favored the top lip a little bit, and that's 5/8 of an inch, the 3/8 return, and then the 11/16 on top. And that's a perfectly acceptable piece. It looks a little bit odder than the other thing, but the reason why is because the top of the angle iron doesn't have a quite, completely smooth radius. Like, it's just a regular 180-degree radius, like a half a piece of rod or something like that. But that's okay. It'll go ahead and it'll hold the windshield just fine. And now what I'll do is I'll take some seaming pliers, and I'll just smash this down just a little bit, just to where it's a 1/4 inch all the way across, because you can see it's just open just a tiny bit this way. And then cut this using some shears, and it'll be done. And that's how I did it. Well, thanks for watching the video. I know I have some nice tools here in the shop, the shear and the brake, but those are the only two that really that I have that you may not have. But you can borrow those, or you can go to a sheet metal shop and have them shear your sheet metal for you. And the brake, usually anybody in the local EA chapter has at least access to a brake. Other than that, it's all hand tools. So you should be able to do just fine. Hope you enjoyed the video, and see you next time.